In this module, we are going to look at the factors that give rise to and sustain circular motion. Circular motion can be viewed as a result of the interaction between velocity of a body and a force that is acting on it. Now, we know that velocity is a vector. So in general, it can change in three ways. Number one, it can change in magnitude. So the speed will change, or the body will start moving faster or slower. Number two, it can change in direction only. So without altering the speed, the body will just change its course. And number three, both speed and the direction might change. Next, let us take a look at the cause of this change in velocity. Any change in velocity constitutes an accelerated motion, and acceleration requires force. So any change in velocity that we see must be caused by a force acting on the body. So let us take a closer look at this usual suspect for change in velocity and how it interacts with velocity. Here are the three basic ways in which velocity of a body and the net external force acting on it interact. In the first case, the force is acting in the same direction as the velocity. So the body speeds up. In the second case, the force is acting opposite to the velocity and the body would slow down. And in the third case, the force is neither in the direction of velocity nor opposite to it. So the body will neither slow down nor would it speed up, but it will still change, and it will change in direction. It is this third case that interests us in uniform circular motion, or circular motion that is taking place with constant speed. So let us move to this menagerie of motions. So we have these three paths. Okay? One is a triangular path, one is like a square, and one is like a regular pentagon. And we are going to set this body in motion, and here we have some sort of obstacles on which the body will bounce and take a different course. Let us see this motion. There. So the body is most of the time moving along a straight line, but then it hits an obstacle. A force momentarily acts on it, changes its course, and then it is again set on a straight line motion. So to change the direction of motion, we need a force. And if you notice here, that force is acting towards the center, like this. We can observe one more thing, and that is in a triangular motion, if we call it by that name, we need this force, this deflecting force, 3 times at these 3 corners. In a quadrilateral motion, we would need it 4 times. In a pentagonal motion, we would need that force 5 times in a cycle. And if we extrapolate this, then in a polygon of infinite sides, like this circle here, we would need that force infinite times, or all the time. And since that force is acting along a center, we have now a key for circular motion. For circular motion or uniform circular motion, we need a force acting on the body which is directed towards the center all the time. And because this force is directed towards the center of that circular path, it is called centripetal force. So at the heart of any circular motion, there must be a centripetal force in one form or another.